The following is a presentation of MAS Institute of Training and Media, a division of Manufacturing Asset Solutions. This is training module number S, PDM 500, Predictive Maintenance Work Orders. This is one in a number of training sessions designed to provide you the knowledge needed to effectively operate version 9 of Express Maintenance and Express Request software. Now, from time to time, we will provide you online webinars that are designed to take your knowledge one step higher. By attending them, you will get real-world answers to problems that users are experiencing in the complex world of maintenance. Enrolling in the EM user group is also another option to learn and stay current with EM. This topic is predictive maintenance and how it relates to a CMMS like Express Maintenance. Some of the main differences between preventative maintenance and predictive maintenance is that preventive maintenance relies on visual inspection, cleaning, and lubrication, whereas predictive maintenance uses electronic sensors to detect defects before they cause breakdowns. Key services for predictive maintenance include, but are not limited to, ultrasound, vibration analysis, oil analysis, infrared analysis, and ultrasonic detection. The IPF curve represents the life cycle of a unit or component from installation to point of failure of detectable potential failure to all-out failure. The proactive domain represents the time from installation to the point that a potential failure begins, and the proactive activities can range from redesign to adding extra safety features. Ideally, an initial PDM survey would be planned directly after installation to check for installation faults as a part of acceptance testing and to establish operational baselines to be used as comparisons for later PDM surveys. Early signs of failure can be detected months before a catastrophic breakdown by using PDM techniques. This allows time for planning production downtime, ordering replacement parts, and planning for manpower being off shift. Where is preventative maintenance in this graph? Well, they can both be running at the same time. However, the ability of maintenance technicians to detect pending failures is likely limited to be in the P5 and P6 area, where the audible noise and high temperatures are exhibited. That is why predictive maintenance can be so valuable. Once a failing component has progressed to the point that it can be detected without the use of sensors, it has entered the fault domain and will often fail within 10 to 15 days. There could also be collateral damage to other components due to excessive heat or vibration caused by failing components being in a fault condition. This leads to an increased cost of repair and an increased loss in production not only from this machine, but possibly from other machines waiting for maintenance. There is also an increased chance of personal injury when running in the fault domain. A catastrophic failure of equipment could create shrapnel as nuts and bolts go sailing through the plant. Running in the fault domain often puts the maintenance team in a state of high stress, which can lead to stress-related illness and injury due to being in the constant state of vigilance. So when should you have predictive maintenance surveys done? Well, after new equipment has been installed as a part of acceptance and baseline testing, when operations experiences high machine-caused product rejects, when motors burn out too soon, when pressures are too low on presses that cause product restrikes, to diagnose air, steam, and roof leaks, when there is an unexplained high use of therms and kilowatt hours, when you have equipment that is thought to be under-maintained, and when you have anecdotal reports from operators that make you suspect conditions exist that predictive maintenance surveys can reveal. PDM efforts require buy-in from operations and maintenance. That's because getting a budget for surveys requires support from both. Operations will need to be fully running for equipment and facilities testing. PDM engineers may need access to running units to perform their surveys. Operations and quality control staff may need to provide operational notes and observations to the PDM engineers. And then when the surveys are complete, there is a chance that maintenance staff will have repair work to do, including the possibility of bringing in contractors to fix problems. Here are some key performance indicators that you might find. Increased production equipment availability due to reduced catastrophic failure over time. Increased product quality due to more reliable machine cycling. Increased performance due to fewer reports of equipment performance degradation. Decreased safety incidents and increased morale due to happier, safer machine operators. Clear decisions being made on active equipment. Use, rebuild, or retire based on PDM data. Increased peace of mind for facility maintenance or operations managers knowing that due diligence has been met. An increased ownership mindset because staff knows that you are working to improve problems, which makes them more likely to report problems earlier. Let's look at how to record predictive maintenance activities in a computerized maintenance management system. In this example, we will use version 9 of Express Maintenance. To see the existing services in your database, go to Administration and select Services. This will display a list of the services for your database based on the service name. Let's look for any existing predictive maintenance services by making the category column current and searching for predictive. Finding none, let's create 4 new services to cover the most common predictive surveys: ultrasound, vibration, oil, and infrared. Click on the plus button, which will move you from the Overview tab to the Data View tab. Type in ANN Vibration Analysis Survey in all caps. The category is predictive, the work group is production, the cost center is related to maintenance labor, the period is years, the interval is 1, the renewal basis is service originally scheduled, and the logic is a calculated date. That means each year on the same date, the scheduler will bring this service up. Save that and close it. Click on the pencil button in the General Notes field, then use the editor to include general instructions. Each survey should be tailored to priority areas. Repeat that process until all 4 of the new predictive maintenance services have been created. Go to Equipment, and then attach the new predictive maintenance services to those equipment units that will be included in the surveys. In this case, the vibration analysis survey will be done on the master fans, which means all exhaust fans will be included. You could also set a master unit for any equipment, including master fans, pumps, motors, compressors, and generators. Set the scheduled date to a time that works for your operations and budget. Here in the Services PMs tab, it is set to July 1st, 2017, and each year thereafter. The service scheduler will show this service due for completion on the schedule via the Maintenance Service Overview. Set the filter forward to be past that July 1st date, let's say August, and pick it, and you will create a new work order. Here's the Create Work Orders button. Here we see a work order that is created for the master fans doing the service, which is a vibration analysis survey. The next step we did was go to Employees and add Rob Trippett, who is a predictive maintenance engineer contractor. Now we added him as an employee, so he will show up in the work order in the services section. When you're working on this, make sure you check the maintenance technician box. And here we see completed work order number 14, which documents the work that was done by Rob Trippett. Took 9 hours. The unit downtime was 10 hours. Here's a look at the worksheet related to the work order 14. The engineer will provide an analysis and conclusion report. These, along with recommendations for a follow-up, should be attached to the unit-specific notes. Well, this completes this training module. We hope you've enjoyed it. We support you for investing your time and yourself to become a better user of the Express Maintenance software. If you would like to talk to a highly recommended predictive maintenance engineer, contact Rob Trippett. His email address is rob.trippett@mas.systems.